this is what I said at the end of last time. I'm going to remind you. To measure efficiency, what they do is they define this thing they call TFPR. What is TFPR? Well, TFPR is really just price times TFP, which is it's the value TFP, if you like. It's multiply the TFP, which is the productivity term in a production function, and so you do that by the price of the good, and you get that. Now, what I showed last time, and I will assume I explained that, is that this is exactly this. It's a product of two things. And this is just the average product of capital. This is the average product of labor in value terms. Again, in value terms, so including the price. But other than that, it's exactly what you think they are. They're the average products, and the average product of each of these things is kind of by the fact that it's a Cobb-Douglas production function, are exactly proportional to the marginal product. So in other words, remember where we started. We started by saying this whole thing by saying that we kind of know that marginal products are not equalized. That's the point I was making about the average marginal product being 22%, but some people have 600%, etc. So the marginal products are not equalized. If marginal products, so therefore, and that's sort of the underlying symptom of inefficiency in the economy is the non-equalization of marginal products, because that's basically saying that there's a resource, it has marginal product of 20 here and 5 here. That means I should move a lot of this stuff from here to here. That's the typical idea that I'm not using resources well. Why? Because there are two uses of it and they're not equally useful in those two uses. Is that clear? So that's why the connection here is very close to that idea. They want to pick up exactly as they should, as the economics of this dictates, the fact that the marginal products are not equalized. But if the marginal products are not equalized across firms within the same industry, these are SI, I is firm I in industry S, then how do you pick that up? Well, how do you so the goal here is the quantification of that effect. How serious is that? How is that? Is there just 1 or 2 or 3 firms? Is it many firms? How do I look at that? How do I generate a data set? The problem comes from the fact that the marginal product is not typically something that's easy to estimate, because the marginal product, estimation of marginal product is sort of kind of one of the holy grails of all empirical microeconomics. You want to change a factor, you see what happens. The problem is always that when you change, you don't observe the change. You can't randomly change the capital endowment or the labor endowment. What you observe is some endogenous moves in different things, and those endogenous moves are never going to be easy to separate from whatever caused them. So we simply don't have the rich data on marginal products that you would need to justify doing a full-scale exercise using marginal product data. We just don't have that kind of marginal product data. So what do? They do this, they use the Cobb-Douglas and they turn it into average products. Now, average products are easy to get because average products are just total amount divided by the amount of capital or labor or whatever you're using. So those are easy numbers to get. You get them there's a lot of work. Let me not downplay what they've done. Every single empirical exercise is a million times more work than you start by. If you just read the paper, you don't realize how much hard work went into it. But nonetheless, it's a much easier thing to do than to try to put in the marginal product. So that's what they're doing. Okay, they're taking the average product And this is really just a geometric average of the average products. They're going to compute that number. Now, one thing they need to do in order to compute it is, it's true that the marginal product is proportional to the average product, but you don't know the constant of proportionality. The theory tells you what the constant of proportionality should be, and so you'll have to somehow, find values of it. In particular, we kind of know that you want to, suppose I want to find the firm level variation in the marginal product. What is the firm level variation in the marginal product? Well, look at this equation here. This equation says that for firm I, suppose the tax rate is the distortion in firm I. It's not really a tax, it's anything that causes distortion. If that number is tau YSI, then because this just comes from the marginal product equation. This is just the marginal product equation. I don't have the time to go through it, but it just comes from the fact that this is the average product. The average product is proportional to the marginal product. What is the constant of proportionality? This is the constant of proportionality. I went through this last time, but you should look it up. Okay? And we still need to know these two numbers. What do they do? Well, they do something which is common in the literature, which is say, let's assume that these numbers are the same in all industries, and we just put some numbers in it, and then we do some sensitivity analysis. What do they do? They set sigma to be 3. Sigma is what is sigma? Sigma is the elasticity of substitution between these goods. So there are different goods here. There are different types of steel or something. This is the elasticity of substitution. It has a very simple interpretation because, remember, this term here comes from the fact that there is a markup. Profits are, revenues are x times cost. And what is that x? X is just sigma over sigma minus 1. So this is just the markup. So one thing you can do is, therefore, you can look at what is the markup in different industries. And typically you find that the markup is something like, something that implies a ratio, a value of something like 3 or more than, typically more than 3. Something more like, because the profit rates, 3 would imply a very high profit rate. That would be 3 over 2. That's 50%. Typically, the number you use is something like more like 5. 5 will give you 20% profits. That's more like what people find. So the profit rates typically are more like 20%. So this number, so 3 is a low number. Why do they choose a low number? Well, I'll say in a minute, try to explain in a minute why. Having a low number typically biases against their finding. So this is what I say. They don't really have the numbers. They're kind of guessing, but the way they do it is they choose a number that's conservative. So they want to choose a number that works against them. So they choose a number that's, and for alpha they use the US, again the US labor share. Remember with Cobb-Douglas, the labor share is the total, is the share of output going to labor is exactly the Cobb-Douglas coefficient. Okay, so they take those numbers, they plug it in, and then they can, then they go, what's the data? So they use the ASI data from India, the Annual Survey of Industries, which is essentially a census of all firms with more than 100 employees, plus a third sample of all the firms between 20 and 100. This is in a sense a very conservative exercise. Why? Because we already kind of got the hint. The McKinsey report we discussed had this fact that the firms that are really for example, in making apparel, the firms that are really inefficient are the one-man tailor shops. Those are excluded from this data set. They don't exist. So we're going to look at inefficiency. When we look at inefficiency, we're not even going to look at the worst firms. We're going to look at inefficiency without the worst firms. Okay. Then for China, they are, again, even less. But it's a census of every firm which has a paid-up capital of more than $600,000. So that's a even bigger firms than in India. So these are really quite large firms. Nonetheless, there's tons of them in China, and so this is, and then what they do, the first thing they do, I'm going to show you just pictures. This is the distribution of TFPR. So give me, before we get to that, what should be TFPR? How should TFPR be distributed, let's say within an industry, if markets work perfectly? It should be a mass point at 1. Or scaled, I guess, that's right. I shouldn't say 1. The way they've done it is going to be a mass point at 1. I'll say why in a minute. But it will be a mass point. Why? Because remember, this is just the marginal product. Marginal products are equalized across all firms. So this number should be the same for all firms. This number should be the same for all firms. Therefore, their product should be the same for all firms. So all firms should have exactly the same TFPR. Now that's a remarkably convenient fact. This is a way to say that, I've just collapsed all this complexity into saying that if the markets work perfectly, this number should be equal to constant across firms. The way they then do what they do is they actually divide this by the average TFPR for the industry. That's what kind of that's why I said they should have if all firms are identical, the average is equal to the individual, and therefore it would be 1. If they're not, it will have a spread. And the main point to take away from this is that the US has is much more concentrated than both India and China. Okay. If you now go back to the numbers, the standard deviation is 0.45, and in India and China, they're about 0.66, so something like that. So they're significantly higher in these countries. Now, the question is, what does that mean in quantity terms? So this is saying something more than what I showed you before. What I showed you before is that there are some firms which have very high marginal products. This is saying something else. This is the average across all industries in a census of medium to large firms. And in that average, we still see that there is a big difference in the spread between US and certainly two things are true. One is that this number is not equal to 1 anywhere. Come back to that point in a bit. And the second is that it's quite a bit more spread out in India and China. That's in a sense this fact. The standard deviation is lower in the US. So in other words, this is saying that this is a kind of a macro fact, not just a fact about a few firms. Okay. Now that still doesn't tell me what the productivity consequence is. What I really want to know is, does this explain why India is poorer than the US? Can it explain? For that, I need to take one more step, and they take it. I'm not going to actually be able to explain it, unfortunately, because it actually takes some computation. But after you do the computation, you'll find that the TFP of a sector S is a weighted sum of the TFP of the firm weighted by this ratio. This ratio is just the ratio we had in the figure, the inverse of that. Okay. This ratio. So this will give you the TFP of that sector. Now, what two things that are being said here. One is that variation in A is not necessarily bad here. Per se, if some firms are more productive, that doesn't. This is not a model which is kind of like saying mechanically that if there's any variation, that's all bad. In fact, variation in A in this model is typically going to be good. Why? Because if resources are used efficiently, then having one very productive firm is better than having a few medium productive firms, because you put all your resources in the very productive firm. There's a natural convexity there. Yeah.
But I mean, I don't understand why all the resources should be allocated to the fields that have a high level of productivity, because in the medium level of productivity, both fields are optimizing. So in that case, we have.
No, they are not optimizing. Remember, the whole point of this is that we are trying to kind of identify how far are the industrial sectors from optimizing. That's exactly the point of this exercise. So we are starting as a premise that they are not optimizing. If they were all optimizing, facing the same prices, then it would of course not be an interesting exercise to do. So if in a world where markets are not doing a great job of allocating resources, what should we want to do? Well, if it were the case that so variation in A is going to typically be an advantage. Now, what is not an advantage in particular is situations where A and this ratio move in opposite directions. High productivity firms should have this ratio being high. Sorry?
I just don't understand why. I may be misunderstanding something. I don't understand why you have TSP with TSP RS, the denominator.
Oh, this is just the average. This is just a scaling. This is a scaling. Okay, let me use the formula I have not explained, so let me not spend much time on the formula. The main idea is that what you want is productive firms to have lots of capital. If anybody has to have lots of capital, who should have lots of capital? It should be the most productive firms. So in other words, what you want is a situation where the correlation between productivity and TFPR is negative. Why? Because high TFPR means you're too small. Your marginal products are high. So if you had to conditional on having a certain amount of inefficiency, how do you want to allocate the inefficiency? You want to allocate the inefficiency so that the firms that are the biggest are the most productive ones. Okay? So that's what's built into this formula. I'm going to. If you don't understand that particular nuance, I think it's still fine. So what they do then is, now that they have that, they can now do the following exercise. So with this formula, they can ask, now I can average this across all the firms. And I can ask, how much productivity loss happens because of this. Quantify the macro effect. So far I've said that China is different from the US. You saw one measure of how different, which is the standard deviation is about 50% higher in China. But I think a much more useful measure is what is the effect of that on GDP? The answer is that now that we have this model allows you to compute that. And the answer is so there are two possible answers. If you fully equalize TFPR within each sector, and that's not everything, all the inefficiency. It could be that steel is much too big in China, and ceramics is much too small. This is not answering that question. It's saying, let me just take TFPR within each industry and equalize it. Remember, they should be equal in under efficient outcomes. If I equalize it within each industry, not trying to do anything across industries. I don't say that, if ceramics is too small, I make ceramics grow and steel shrink. I'm not going to try to do that. I'm going to take steel, the size of steel the same, just reallocate resources. So if I equalize TFPR, what would happen? Well, TFP in India would go up by 225%, in China by 90%, in US by 40%. So these are big effects. The reason why these effects are so big is because not only is it the case that there's more dispersion in TFPR in let's say India, but the correlation is wrong. Remember I said that it matters what the correlation is. The biggest firms tend to be the worst. It's not just that the biggest firms have very low TFP.
But it doesn't make sense.
Sorry.
It doesn't make sense because you have said that most that fields that are very big are the most productive ones.
I think, let me try to be precise. What I said is that if firms were productive, they should be very big in the efficient solution. Now we're asking a different question. We're asking the question, why is it that TFPR in India why is productivity in India low? And the reason is that we have the opposite in India. We have that the biggest firms tend to be the least efficient. The correlation is wrong. That's why these effects are very large. The second exercise you can do is say that, look, maybe we shouldn't try to achieve the level, zero variation is probably not realistic. If we move to the US joint distribution of TFPR and TFPQ, so it varies as much as in the US, and the correlation is the same as in the US. TFPQ, remember, is just productivity. So productivity, and this is TFPR. If I set the productivity, the correlation between those two to be the same as it is in the US, I would increase TFP in India by about 50% and in China by about 30 to 45%. So these are very big effects because basically if you double TFP, you can explain most of the variation across countries. There's very little residual variation. All the unexplained variation across countries is about between countries, but between, let's say, India and the US. Some of the difference comes from the fact that India has less resources. Take that out, what's left is a difference of a factor of 2. So these are enormous differences. You can explain about 50% of all the variation. That's their claim, yeah.
So in this exercise, they try to look at the effect of the distribution of TFP.
Correct.
But so this is weighted by the absolute level of TFP, no? So if you were to do this exercise
No. What they're doing, remember, that's why I was trying to say this ratio is what they're scaling it, all of it by the average in the industry. This all scaled by the average, and that's all that matters.
But the average is country dependent.
Sorry?
But the average here is the one in the country.
but, sorry?
The average that they consider is the one of the, it's country specific.
Absolutely. But the point is that, remember, this ratios all that enters, so that within a country, within an industry, all that matters is the relative. It doesn't, for the efficiency, it doesn't matter. Everything else enters through the level of these the marginal products. The marginal products are going to be lower in a country which has more resources. But this ratio is going to still be equal across all firms. So the so this number would be lower in every country because the marginal products would be lower. A country which has more capital and labor will have lower marginal products. This product would be lower. The US would have a lower product. But it would not be that doesn't matter for this exercise. This exercise is just about equalizing the ratios.
Maybe I misunderstood what you said and I didn't read the paper yet. But the question was that is a bit related to the previous one, which is that is TFP really exogenous with respect, for instance, to financing constraint and the allocation of capital?
Okay.
So that, I don't know that that's, I tried to say nothing about that, and I was careful. A reason is that that's not, I think the spirit of the exercise is to say, suppose this is the data I observe. Is this data consistent with large effects, potentially large effects? They're not saying there's an instrument I have for fixing this problem. It may well be. Then they're saying nothing about the question of policy, which is the one you're asking. They're just saying, if I observe this much dispersion and this correlation between this number and this ratio, what consequences does that have? And their point is that if I move from what we observe in the data to the US correlation between this number and this ratio, I would increase productivity in India by 50%. That's all they're saying. Then maybe that's not possible, maybe there are particular policies that would make it possible, but they're not saying anything about that. And I think they're trying very carefully to avoid answering that question. Did I answer your question from before? Sorry? Okay. Okay, I'm going to now kind of, maybe before I come, so what would you worry about if you looked at this data? Sorry?
Maybe we have some trends in the time series data, some cycles maybe.
Okay, so actually there's something related to that. You might say, look, maybe what we are observing is some adjustment, some endogenous adjustment that has to happen basically. So for example, maybe when firms are building, the productivity is small to start with, and maybe that's actually efficient. We're not taking into account the fact that there is some option value to shutting down firms. So when I start a firm, I start selling chocolate flavored cheese. I might try it out before I expand that because people might hate it. So I might start small and expand later, right? That's a natural kind of business decision I would take, and this model doesn't allow that. The option value of exit. Here the capital allocations are symmetric across periods. It's not that when I invest in my fancy shop which sells chocolate flavored cheese, that shop I can shut it down in a minute is basically what I'm assuming, and that may not be realistic. I think it's probably reasonable to assume that that's not realistic. So you might worry about, for example, is it the case that, so strategic underinvestment by new firms, that's the idea. That maybe it's the case that we observe this pattern, but it makes perfect sense. there are a lot more young firms in India, and those young firms are the ones that are deliberately underinvesting, and therefore they are actually that's efficient. The reason why we see more variation in India is India has more young firms. Young firms should start small. You should not expand your chocolate flavored cheese shop too much before you try it out, and as a result we see many more small firms in India which are need to grow, but eventually they will grow. Some of them will go out of business, others will grow. We don't see that. In India in particular, the smallest firms are actually relatively the biggest. The youngest firms are the biggest. Their TFPR is lowest. To say that TFPR is low is to say your marginal product is low, meaning you are big. Relative to how productive you are big. So it's not the case that you don't find this pattern. So it's not the case that that's what's happening. No relation in China either. It's also not the case that if you look at learning by doing, it's not the case that the firms which have low TFPR today are going to have high TFPQ later. You start by being a little too big, but you're going to be better in the future. And so your TFPQ is going to keep going up. You don't find that. The correlation is the opposite. The firms which are relatively small, meaning relative to the productivity, they're too small, they have high TFPR, tend to be the firms that also grow their productivity fastest. So there are good firms and bad firms. Good firms are too small, their productivity grows very fast, but they remain too small. And bad firms are too big relative, and they don't shrink. That's sort of the pattern you see. So it's not that. So what else could it be? I don't have the time to go through all the arguments. What one thing, if you worry about one thing in looking at this data, what would you worry about? We sort of discussed a little bit that just now. So let's say that we have already taken care of that. What did we use here? We use what are we using here? All of this here, or any of these pictures? What are we using? They're not doing any time series. So let me just keep the time series out of the way. I'm using firm level data to infer variation. Think of all the stuff on income distribution. What do you worry about? You worry about measurement error. One reason why you'll think there's lots of inequality in the income distribution data is there's lots of measurement error. If everybody was equal but there's tons of measurement error, we think there's tons of inequality. Same problem here. Every firm could have the same TFPR, but there's lots of measurement error, which surely there is. You would see this pattern. So that's one general worry. So they try to do all kinds of things about it. For example, instrumenting this thing I really hate, which is instrumented with lagged values, which makes no sense to me. So you do all kinds of things to fix it. But if you think that all the measurement is correlated for very good reasons, some firms are lying about their output because they are not paying their taxes, then that's going to be correlated over time. It's not clear you can fix any of that by doing any of these things, but yes, so they do all those kinds of things and they don't find anything, but I'm not totally reassured. So if I had to worry about these results, I would say the first order worry is measurement error. And one exercise I've never seen anybody do is to say, let's play with the data. Let's add measurement error and do sensitivity analysis. Just play with their data. Go back, put in measurement error, some measurement error that you make up, and see how much changes. How much can you explain? Because remember, they still have one very strong thing, which is that measurement error typically tends to be uncorrelated, at least across firms. And if it's uncorrelated, then you shouldn't, then the correlation between A and A and TFPR should still be, is still a rather remarkable fact, and you should not get that correlation. If I just added measurement error, I should just, that correlation should go to 0 basically. So the fact that, so they seem to have something in the data which is somewhat believable, I think, and that's now that's not a strong endorsement, but I think it's still, so I think it's a worthwhile project. Yeah.
So it does make sense to believe that the main measurement error in this kind of data is the level of capital.
Level of capital, surely, but even level of revenue. Firms might be lying about the revenue because they don't pay taxes. There's all kinds of reasons why you might think that the revenue. But you're right. So that would be one way to think about it, is if all the measurement error was in capital, what would I see in the data? So that kind of exercise I think is useful to do. I'm going to skip because I want to go to a couple other topics. Okay, so now I'm going to skip completely. Okay, so we just did like hardcore, empirical exercise. I want to go to theory. And I want you to think about this world we just described, where TFPR is not equalized. Marginal products are not equalized. We started by making the observation that all of growth theory is built on the assumption that marginal products are equalized. That's what the aggregate production function is. That was a long time ago, one Monday. So maybe that thought has escaped you, but assuming that you remember it. So one clear next step is, suppose we give up on this equalization of marginal product, can we do growth theory? How do we think about the world? It's fine, it's great. I showed you empirical evidence, marginal products are not equalized, this curve looks like that. It should be a point mass, it looks like that. But now that I said it, is all ruined. So let's do some growth theory. Yeah, and I want to claim it's actually not hard. You just have to think about it. You have to model the distortion. You have to think about what the distortion is. But once you model the distortion, the growth theory is not that hard. But okay. So I'm going to assume now individual production functions, one input, capital. It could be human capital, it wouldn't change anything, it's just a label. One input. Production function, right now I've said nothing about f of k. I'm not assuming it's concave or anything, but I'm going to assume that the production functions are just a function of k. People have CRRA preferences. Again, this is not very important. Almost everything you could do without CRRA preferences, but it's going to formulas will look a little simpler. So these are the preferences. People are forward-looking. They have a discount factor delta, and so they discount the future. They maximize discounted utility. And finally, this is what I said, you have to model the distortion. I'm going to model one distortion here. And the distortion I'm going to model is the one in the capital market. I'm going to assume a very, very simple form of it. To assume that basically the amount you can borrow is a linear multiple of your net wealth. How much wealth do you have in hand? So when you go to the bank asks you, this is sort of roughly what banks do. They ask you how much, how much equity can you put into your house, for example. They say, you have to put 20% of the value of the house into your house. That's literally saying it's a linear multiple of your wealth. Okay, so now I'm going to assume in addition that as the interest rate goes up, that tightens. And that also you can easily justify using a kind of a standard micro model of incentives that, when the interest rate is higher, it makes people's incentive to default on the loan is higher, so banks tend to want to lend you less. So lambda prime is negative. I get to borrow, if I have $1 of wealth, I got to borrow 1 plus lambda dollars. I got to borrow, 1 plus, I get to borrow, that's not right what I said. If this is my wealth, this is the total amount I can invest. Some of this I own, so lambda minus 1. Lambda minus $1 is what I can borrow, the way it's done, okay? So if I have $1 of wealth, I can borrow an additional lambda minus $1. So if lambda is 2, I can double my $1. And that ratio is declining as R goes up. Okay? So this is just boilerplate. You should have see this is the Euler equation. I already talked you through this before. The marginal rate of substitution over time should be the discount factor times the interest rate, which from the CRRA assumption is just that ratio, the growth rate of your consumption. Okay. Now, this is only true for people who are, so let me go back for a second. Let's write down the optimization problem actually before we do that. So what are you maximizing? Well, think of the world as when every period, you start with a certain wealth. Out of the wealth, you have to decide how much you're going to eat because you're hungry. It's lunchtime. So you eat certain amount. What's left is what you can invest. Okay? Now you can multiply, that gets multiplied by a certain amount because you can borrow, you can borrow some lambda multiple of that, or lambda minus 1 multiple of that. So the total amount you can invest is bounded above by this multiple. This is how much wealth you have. This is how much you add by borrowing, lambda minus 1. So this is the total amount you have, and your K must be less than that. You can't invest more than you have plus you borrow. Okay, so this is and then what are you trying to achieve? Well, you're trying to achieve you're going to choose your K to maximize this expression because you want to, given that you have eaten C, now all you want to do is maximize your income. Conditional on having eaten C, all you want to do is maximize your income because that's give you next period wealth will be the highest. So next period wealth is essentially this number, WT plus 1. What is it? It's a maximum of this expression. It's your, think of it as being, you produce this much output, pay the interest on the entire amount of the output, of the capital, and then this much you get refunded because this is the wealth you had. You had some, so you don't pay the interest on it. So think of that as being, this gets refunded to you, this is how much you pay. So this is all kind of elementary. Now going back to, now in this problem, the only thing that changes from the standard maximization problem is that you might be credit constrained. What does credit constraint mean? Literally means this constraint binds. If this constraint binds, then your incentive to not consume is higher. Why? Because if I don't consume, I relax this constraint. So this is shadow price on this constraint, which goes into your optimization problem. In addition to the usual trade-off, which is that if I don't consume today, I get more tomorrow. If I don't consume tomorrow, I can borrow more today. And if I borrow more today, then I can invest more today, and that's going to give me a bit more wealth tomorrow. So that says that if your credit constraint, your marginal rate of substitution will be higher than the standard price. This is the standard price. And if you're not credit constrained, it's equal. Okay. Much of what I'm going to have to say comes from staring at these two equations.